you can see all of your I can statements, and there's quite a few of them. I can determine if something, what model fits it. I can determine the characteristics. Is there a rate of change? A y-intercept? Is it linear, nonlinear? Distinguish between linear, nonlinear, and communicate similarities. Looking at graphs and tables. So, a function is a relationship that pairs the input with exactly one output, right? That's a function. Function, each input, one output. Then we're going to get more specific. So, if we are looking at that, we are going to be talking about a linear function. Linear function. A linear function is when we are looking at the graph. I look at the graph of a linear function. It's going to be a nice straight line. The word line is in linear, right? So a straight line when I look at that. So if I am graphing, that straight line might be a horizontal line. Is that going to be a function? Yep, and it's linear. It might be slanted this way, right? It might be slanted this way. But it's exactly a nice straight line. It has these arrows on it usually. So if you see a straight line, linear function. In a table, how do we know in a table what a linear function looks like? It's going to be repeated addition. Now someone said, oh, repeated addition or subtraction. Well, subtraction can be adding like -2 repeatedly, right? So that would be repeated still addition. Just that you're going to add -2 or subtract 2. And when we look at an equation, they give it of this form, y equals mx plus b. What I want you to put down with that, besides y equals mx plus b, is your variable x and y are going to be to the first power. When it's a linear equation, you will not have any exponents. You will also not have it being divided by x. So if you think of this type of an equation, this is going to be linear. And then nonlinear, what does it look like? It's going to be not any function that is not linear is going to be nonlinear. So when we look at nonlinear, we're going to explain a little more, is just going to be not a straight line, right? Just not that straight line. Now, seems kind of straightforward when we look at our equations. So when I look at the graph, it's not a straight line. If it's a table, it won't show adding the same thing. It might be add 2, then add 3, then -5, then +4, right? That would not be constant addition. If I'm looking at an equation that is nonlinear, it might be something like this. Y equals x squared. That's going to be nonlinear. It might be y equals absolute value of x. That is definitely nonlinear. So if you're writing these examples down, variable to the second power, right? This variable has absolute value with it. What else could we look at for an equation? Well, what if I have something like y equals 4 divided by x? This is also nonlinear. And I'll show you on the Desmos calculator how you can do a real quick check of an equation. But the key thing you want to really look at is it's not to the first power, right? This variable is to what power if it's in the denominator? Does anyone know? When it's in the denominator. It's actually a 1 down here, but if you move it up, this is the same as this, 4x to the -1. So that kind of throws people off because they'll say, oh, this is x to the first, but because it's in the denominator, this one, notice the x is in the numerator. This is not really x to the first power, it's x to the -1. So those ones kind of will throw people for the linear, nonlinear, okay? So, as you look at this situation, it says, the table and the graph show a relationship between the number of photos you take and the amount of memory left on your camera. So we're thinking back in time when you maybe had a digital camera and not just your phone to take all the pictures. So it says, is this a function if we look at this table and we look at the graph? Do you think this is a function? Each input have one output? Definitely. If we look at the graph down below here, each input, we get different outputs, and it's actually showing repeated addition. We're adding -3 each time. So it says, is it a function? Definitely, yes. Each input has one output. That'd be the easiest way to answer that. Can you write all of this? Sure. Each input has one output. As you take one picture, you use more memory. Is it linear? In this case, it is linear. First off, if we were looking at that, we could say because when we look at the graph, it's a straight line. Why aren't we connecting this with points? This is still a discrete graph. And the reason we're not connecting it is each picture uses a different memory, but it's not continuous, right? If we look at the table, repeated addition, adding -3. So the question is, could we come up with an equation? And they didn't give us an equation, they just gave us a table and a graph for this one. But we easily could come up with an equation, and we're going to look at that. So, looking at this next pattern on the top of the next page. So, you know, sometimes when you take those tests and they say, oh, here's a pattern. It tells us it is a function, right? So we know it's a function. We're just trying to determine, is it linear or not linear? So when we take a look at this first one, one square gives us an area of 1. So plot the points. 1 at 1. At 2, it's at 4. First off, if I'm looking, my picture number is X and my area is Y. I'm thinking that those is ordered pair, right? So this is the picture number. And on the side, my axis, my y-axis, is really the area. When you start graphing that, and so now we're going to go to 3, it's up at 9, and 4 is 16. Does it look like it is a function? I mean, we know it's a function. Does it look linear?
Yeah.
No. Maybe at first it kind of did, but did you have repeated addition? No, because here it's like you're adding 3, then you're adding 5, right? Then you're adding, so it's not adding the same thing each time. So, if we are looking at this, you guys recognize the pattern? What were we doing to each number? We are times itself, so the equation might be y equals, or area equals, x squared. And we definitely said because first off we have a variable, there's not repeated addition, it's not a straight line, this is non-linear, right? Non-linear. Angles and the perimeter. Now, I want you to actually think of starting at 0. If we had no rectangle, and I do not want you to put in the perimeter, I want you to leave that. I want you to do for 1 rectangle, 2, 3, and we'll actually do 4. But the reason we want the 0, 1 is this kind of helps us when we write our equation. So at 1, what was your perimeter going around there? 14, right? 6 plus 1 is 7, 7 and 7 is 14. You have 2 of them put together, right? So you got 6 and 6 here. We have a total of 16. 3 rectangles, right? We're up to 18. And the 4th one, we're at 20. So, as my x increases by 1, my y is increasing by how much each time? 2. That's my rate of change when I go to write my equation. So I'm going to be saying y equals 2x. What's my 0 point? Now, if I continue to add 2, I know my x is going to be 22, 24. But if I go backwards, I know it's not possible to find a rectangle with no sides, 0 rectangles. But if we're thinking of this pattern, if I go back, what number should I have here? Well, it should be 12. That helps me to write an equation. This is a really important point. We're going to talk about it a lot in the next unit. It's our y-intercept. Y equals 2x plus 12. How can I check if I did it right? Plug in 2 here. If x is 2, 2 times 2 is 4. 4 plus 12 gives me 16. If I plug in 4 for x, 8 plus 12 gives me 20. It checks, right? So it has to check when I do that. So would this be linear or not? So now we're going to plot the points. So at 0, we want 12, right? At 1, and really we wouldn't have that one. 14, 16, 18, 20, if we are looking at that graph. And this would be linear. Okay. Is it going to be discrete or continuous for our graph? Should I put a line here? No, because we just have one rectangle and we've only added to its sides. You can't have a half of a rectangle added into that perimeter or a decimal. Question? If I look at the two graphs, linear, nonlinear, what would we say for both of them? Nonlinear for both, right? This one is nonlinear, it's not a straight line, right? Same thing for both of these, both nonlinear. Well, now we need to look at our tables probably a little more carefully. And as we look at those tables, that first one, do we see constant addition in our y?
Yes.
So this is going up by 1 each time, right? And this is going up by 3. 5 plus 3 gives us 8. 8 plus 3 is 11. 11 plus 3 gives us 14. Linear. If I asked you why, constant addition. And we could say constant addition of 3. How about here? No. Our x values are all going up, but first we go up by 2, then we go up by 1, then we go up by 10. Nonlinear. Last one.
Yes.
Linear.
Yes. Linear because what are we doing?
Subtracting by 11.
Subtract 11. So constant addition. Great.
What is constant subtraction?
Adding negative 11.
Oh,
okay. But I would agree. Constant addition really or subtraction. When you think of the definition as constant addition, I would take constantly subtracting 11. Same thing. So now we're going to look at this next part. And it says, okay, now we're comparing two functions. And this is going to be the key part for the test on this unit. I'm really going to ask you to explain and to give your reasoning thing. So if your smartphone is already charged at, April wants to charge her smartphone and her tablet. Her smartphone is already charged at 25%. She's starting to charge it. It takes 20 minutes to charge 10% of the smartphone battery. Her tablet is at 18%. The time is when she starts to charge it, and it takes 12 minutes to charge 12% of the battery. Okay? So if we are looking, they give us our table. So every 12 minutes, the tablet goes up by 12%, right, for our constant addition, if we are looking, right? Here, are we constantly adding the same thing too?
Yes.
But it's in every 20-minute increment. So it says compare and contrast and give at least 3 reasons for your answer. So if we are looking at them, do they both look linear?
Yes.
Okay, so that'd be one thing we would definitely want to say. One of the things I want to start off with is both functions are linear. So if you're comparing them, you want to tell me something about both of them. The next thing I know is I notice at 0. I would want to put that down. That's a pretty important part. So at 0 minutes, the phone is at 25%, the tablet's at 18%. The next thing I want to put down that a phone is charging faster. 1% per minute, right? If we are looking at it. It tells us that it's going up 10% if we are looking at this. Right information as you look at that. So tomorrow we will be looking at that next page of your notes. You've got 2 more pages of notes. Tonight, I'm gonna be handing back your homework from last week. The most common mistake for most of you was when you were asked to graph, tell the domain and range, you didn't do the graph for those two questions. You will have to do a graph on the test, so I'm gonna be handing that homework back that I checked. But in this one, it says, that's question number 1. Make sure you represent it in a table. You need to do words, you need to do an equation, and a graph. So, I don't know if some of you, when you checked that assignment, I think it was B2 that we handed in, and you didn't actually do the graph for the domain and range, you will have to do that on the test. So in this one, you're not going to have a negative graph, but your answer should look something like this. So if we look at question 1, 2, or 3, I don't care which one. What one do you want to look at? So let's start with number 1. Okay. So as we take a look here at number 1. So for each one, we're looking at the relationship. Triangles to perimeter. 1 to 3, 2 to 4, 3, 5. 4 should be, if we were going to continue that, what number should we be putting in? 6. 5 would be 7. 6 would be 8. So does it look linear at this point? Yes. Next thing we want to do is says, oh, this is 12. Well, what should this be if that's 12? Okay, right? So it's not going up. They're just asking you, okay, where, like they're missing some. What would 12 and it should have been 10. So you're finding the missing one, right? We now want to write it in words. So in words, what's happening to our picture? Each time we increase by 1 triangle, what happened? The perimeter goes up by how much? 1. Okay, so the perimeter is, if we are looking, the perimeter is increasing by 1 for each triangle, but how is it related to the number above? So, equation. When you look at that equation, you might want to think of what's the 0. So what's the 0? It really isn't going to be, but it's going to be 2, right? So my equation is going to be that the perimeter is equal to, how much is it going up by each time? Plus 1. 1 times the triangle, where triangle, I'm going to use N for triangle, P for perimeter. Could you use Y and X? By all means, Y equals 1X or 1N, right? But we started off at plus 2. So when you write the words part, I might say perimeter, right? What's happening to the perimeter is, how could we say it, than the number of triangles? Perimeter is always how much more than the number of triangles? It is always, perimeter is 2 more, right? That's the plus 2 here. The perimeter is 2 more than the number of triangles. So I wrote my answer in words. I wrote an equation. Now I need to make a graph. When you make your graph, you should be able to make your graph right in that space to the side there. If we are looking at that graph, what should be on my x-axis? What am I talking about? That's my number of what? Triangles. That's going to be the triangles down here, right? So this is my triangles. This is the perimeter. Okay. Should it be continuous or discrete? Should we connect the dots or just dots? Just dots. Don't connect it, no line. Okay. And then you're trying to look. They don't ask you linear or nonlinear for this part. They just want you to do this. Okay. Come up with the equation, write it in words, make a graph. When you get to the next page, if you turn it over to the back, this is where you're asked linear or not linear, and it says explain. Okay. So when you're